In section 6.1, we're looking at the greatest common factor and factoring by grouping. Our learning objectives are to find the greatest common factor of a list of integers, find the greatest common factor of a list of terms, factor out the greatest polynomial factor from a polynomial, and factor a polynomial by grouping. Find the greatest common factor for each list. Example A, the numbers are 16 and 6. We begin by listing the factors of each of those numbers. The factors of 16 are 1, 2, 4, 8, and 16. These are all the numbers that go into 16 and without any remainder. Now let's look at the numbers, the factors of 6. The factors of 6 are 1, 2, 3, and 6. So we look for the greatest common factor, what they both have in common. They both have 1 and they both have 2 as common factors. So the greatest common factor of 16 and 6 is 2. For example B, the numbers are 18 and 24. The factors of 18 can be listed in one column, or you can list them in pairs. 18 is the same thing as 1 times 18, so 1 and 18 are both factors of 18, 2 times 9, and 3 times 6. So the factors are 1, 2, 3, 6, 9, and 18. Let's list the factors of 24. 1 times 24, 2 times 12, 3 times 8, and 4 times 6. So the factors are 1, 2, 3, 4, 6, 8, 12, and 24. So the greatest common factor is the largest number that they have in common. They both have 1, they both have 2 as a factor, 3, 6, and that's it. So we can say that the greatest common factor, the greatest of all those that they have in common, is 6. For example C, the numbers are 15 and 21. The factors of 15 are 1 and 15, 1 times 15, and 3 times 5. And the factors of 21 are 1 times 21 and 3 times 7. So they have some that are in common. They both have 1 and 3 as factors. So the greatest common factor, the GCF, is 3. In example D, the numbers are 12, 28, and 40. The factors of 12 are 1 times 12, 2 times 6, and 3 times 4. The factors of 28 are 1 times 28, 2 times 14, and 4 times 7. The factors of 40 are 1 times 40, 2 times 10, 2 times 20, 4 times 10, and 5 times 8. So let's look for the greatest common factor. They all have a factor of 1. They all have a factor of 2. They all have a factor of 4. Then it looks like the greatest common factor of 12, 28, and 40 is 4. Let's find the greatest common factor for each list. In example A, we have 15m squared and 25m to the 5th power. So our greatest common factor is going to be the greatest common factor of the coefficients, the largest number that goes into both 15 and 25. That greatest common factor is 5. Since both terms have an m, they both have an m in common, so that's a common factor. And we take the smallest of those that they have in common in terms of the exponent. The greatest common factor is 5m squared. For example B, our terms are 40x squared and 20x to the 7th. So we look for the greatest common factor of the coefficients of 40 and 20. The greatest common factor there is 20. and they both have that common x variable, so the common factor is the smallest exponent of that variable. So 20x squared is the greatest common factor. Let's look at example C, negative 28x to the fourth and 56x to the fifth. So the greatest common factor of that negative 28 and 56, the largest number that goes into both of those is 28. 28 does go into 56. 28 times 2 is 56. And they both have that variable x. So the greatest common factor includes the least exponent, or x to the fourth. The greatest common factor, for example D, 21m squared n to the fifth and 35mn to the fourth. We begin by looking at the greatest common factor of 21 and 35. The greatest common factor there is 7. They both have a variable m, so we take the m with the least exponent, m to the first. And then they both have the variable n, so we take the n with the least exponent of 4. So our greatest common factor is 7m n to the fourth. Factor out the greatest common factor from each polynomial. In example A, we have the polynomial 5a plus 15. We want to factor out the GCF. We begin by finding the greatest common factor of 5a and 15. That greatest common factor is 5. Now what we're going to do when we factor that out is divide each of those terms by 5. So we take our original polynomial 5a plus 15 and we're going to write it as a product of that greatest common factor 5 and what we get if we divide out each of those terms by 5. If we take 5a and divide it by 5, we get a. If we take 15 and divide it by 5, we get 3. So when we factor out the greatest common factor of 5, the result is a plus 3. Our answer written in factored form is 5 times the quantity a plus 3. Now with factoring, you can always check your work by using the distributive property here. When you multiply 5 times each term in the parentheses, you get 5 times a, and 5 times 3 is 15. So 5a plus 15 is our check step, and notice that is exactly what we started off with. Let's look at example B. First begin by finding the greatest common factor. The greatest common factor of 56z and 8 is 8. So we're going to take our 56z plus 8 and we want to factor out the greatest common factor of 8. So we're going to write this as a product, 8 times a quantity. And to get that quantity, you're going to divide each of those terms by 8. 56z divided by 8 is 7z, and 8 divided by 8 is 1. So in factored form, factoring out that greatest common factor of 8, we get 8 times the quantity of 7z plus 1. Again, you can always check that step by using the distributive property. Since this factoring technique is the opposite of the distributive property, we can multiply 8 times 7z to get 56z, and 8 times 1 is 8. That's exactly what we started off with, so we have checked our answer. In example C, we have y to the third plus 2y. Begin by finding the GCF of y to the third and 2y. They both have a y variable, that's the only thing they have in common, so you take out the least power, the least exponent. The greatest common factor is simply y. We're taking our y to the third plus 2y, and we're going to factor out that GCF of y. When you're factoring it out, it's like you're dividing it by y. Y to the third divided by y is y to the second power. And then 2y divided by y is 2. So in factored form, y to the third plus 2y is written as y times the quantity y to the second power plus 2. Again, you can always check that factoring technique by using the distributive property. Y times y squared is y to the third, and y times 2 is 2y. That's exactly what we started off with. We're going to factor the polynomial 5x to the third plus 10x to the fourth. We begin by finding the greatest common factor. For the coefficients of 5 and 10, the greatest common factor is 5. For the variables x to the third and x to the fourth, the greatest common factor is the variable with the least exponent, so 5x to the third. We can take our polynomial 5x to the third plus 10x to the fourth and write it in factored form by taking out that 5x to the third from both the first and the second term. When you're taking it out, it's like we are dividing each of those terms by 5x to the third. So 5x to the third divided by 5x to the third is 1, and 10 divided by 5 is 2, x to the fourth divided by x to the third is x. So in factored form, we can write that polynomial as 5x to the third times the quantity 1 plus 2x. In the second example, E, we have 16z to the fifth power plus 8z to the third power minus 12z. We begin by finding the greatest common factor of the coefficients 16, 8, and 12, and 4 is the greatest common factor of all three of those coefficients. All of these terms have the variable z, so we factor out z with the smallest exponent of 1. So we can take our polynomial 16z to the fifth plus 8z to the third minus 12z and factor out the greatest common factor of 4z. And we divide each of those terms by 4z. When we take the first term 16z to the fifth divided by 4z, 16 divided by 4 is 4, and z to the fifth divided by z is z to the fourth power. And then we take the second term 8z to the third, factor out the 4z. We divide 8 by 4 to get 2, and z to the third divided by z is z squared. And the last term, negative 12z divided by 4z, we get negative 12 divided by 4 is negative 3, and z divided by z is 1. So our answer in factored form is 4z times the quantity 4z to the fourth plus 2z squared minus 3. In example F, we have x times the quantity y squared minus 2 plus 3 times the quantity y squared minus 2. So in this case, we're looking at our GCF of these two rather large terms. In terms of x and 3, there's no common factor, but we see that they both of these two big terms have a common factor of y squared minus 2. So that's what we're going to factor out of that polynomial. X times y squared minus 2 plus 3 times y squared minus 2. We are going to factor out that common factor of y squared minus 2. When you factor that out, it's like you're dividing both of those big terms by y squared minus 2. Y squared minus 2. And then we can simplify this. When you take the first big term of x times the quantity y squared minus 2 and factor out the y squared minus 2, you'll have left x. The second big term of 3 times the quantity y squared minus 2, factor out the y squared minus 2, and you're left with 3. So our simplified form is the quantity y squared minus 2 times the quantity x plus 3. Let's factor 6a to the 8th, b to the 9th, minus 8a to the 3rd, b to the 4th, plus 2a to the 2nd, b to the 3rd, plus 4a to the 5th, b to the 3rd. The greatest common factor of each one of those, looking at the coefficients of 6, negative 8, 2, and 4, the greatest common factor is 2. We see that all of the terms have a variable a, so we factor out the least exponent, which is a to the 2nd power. Each of those terms have a factor of b as well, so we factor out the least of those exponents, which is b to the 3rd. We can write this polynomial in factored form with 2a squared b to the 3rd out in front of the parentheses, and then we're going to factor out that quantity, that GCF, from each of those terms. In other words, we're dividing out the 2a squared b to the 3rd from each one of those terms. So we begin with the first term, 6 divided by 2, we get 3. a to the 8th divided by a to the 2nd is a to the 6th. And b to the 9th times b to the 3rd is b to the 6th. Remember the quotient rule for exponents where you're subtracting those exponents. Now we're going to factor out from the second term 2a squared b to the 3rd. Negative 8 divided by 2 gives us a minus 4. A to the 3rd divided by a to the 2nd is a. And b to the 4th divided by b to the 3rd is b. For the third term, we're dividing out the 2a squared b to the 3rd. And 2 divided by 2 is 1. A squared divided by a squared is 1. And b cubed divided by b cubed is 1. And then we're factoring out of the last term, 2a squared b to the 3rd. And we get 4 divided by 2 is 2. A to the 5th divided by a to the 2nd is a to the 3rd. And b to the 3rd divided by b to the 3rd is 1. So in factored form, the greatest common factor for all of those is 2a squared b to the 3rd times the quantity 3a to the 6th b to the 6th minus 4ab plus 1 plus 2a to the 3rd power. Now we're going to do a method called factoring by grouping. We're going to factor each 4-term polynomial by grouping. Typically, when you're faced with a polynomial factoring problem that has 4 terms, this is one approach you may want to start with, the factoring by grouping method. We're going to group these polynomials with the first 2 and the last 2 terms grouped separately, and then find the greatest common factor for each of those groups. So in example A, the polynomial is 8y squared minus 12y plus 10y minus 15. Let's find the GCF for 8y squared minus 12y, and the GCF there would be 4y. And also find the GCF for the last 2 terms, 10y and minus 15, which is 5. Now we're going to take that polynomial and factor by grouping, factoring out the GCF from each one of those terms. So I'm going to factor out a 4y from just the first 2 terms, knowing that factoring out that 4y is the same as dividing both those terms by 4y, bringing that out in front. So 8 divided by 4 is 2, and then y squared divided by y is y. And then the minus 12y divided by 4y, minus 12 divided by 4 is minus 3, and the y divided by y is 1. So that's what we get when we group the first 2, factoring out the 4y, you're left with 2y minus 3. In the last 2 terms, the greatest common factor is 5. We're going to factor out the positive 5. And when you do that, you're dividing each of those terms by 5 to get the result in the fractions, in the parentheses. And we get 10y divided by 5 is 10 divided by 5, which is 2, minus 15 divided by 5, which is 3. Now take a look at these new larger groups. We have the first group of 4y times the quantity 2y minus 3. We have the second group of 5 times the quantity 2y minus 3. We've got 2 big groups here. We've got a group of 2 larger terms. And what these both have in common is this common factor of 2y minus 3. So we are going to factor out that which would be our GCF out of both of those terms is 2y minus 3. So we can write this as 2y minus 3 times what happens when we divide each of those by our greatest common factor. When you factor out the 2y minus 3 from both of those big groups, we can say that the first grouping, 4y times the quantity 2y minus 3, divided out the 2y minus 3, you're left with just 4y. And in the second group, when you take the 5 times the 2y minus 3 and divide out the 2y minus 3, you're left with 5. So our answer in factored form is the quantity 2y minus 3 times the quantity 4y plus 5. In example B, the polynomial is 15a to the 6th minus 25a to the 3rd minus 6a to the 3rd plus 10. Let's group the first two terms and the last two terms and take out the GCF. For 15a to the 6th minus 25a to the 3rd, the GCF is 5a to the 3rd. For the last two terms, the GCF is 2. Because this middle sign here is a negative, we're going to factor out a negative 2 from the last group. So we look at our polynomial in two groups, factor each one of those groups, the greatest common factor. So we're going to factor out 5a to the 3rd from the first grouping and 15a to the 6th. When you factor out that 5a to the 3rd, it's like we're dividing it out. 15 divided by 3 is 5 is 3. A to the 6th divided by a to the 3rd is a to the 3rd. And then we're dividing the second term by 5a to the 3rd to get negative 25 divided by 5 is a negative 5, and a to the 3rd divided by a to the 3rd is 1. Now in the second grouping, we're going to be factoring out a minus 2 there. And we will get, when we take the third term of negative 6a squared and divide it by a negative 2, the negative 6 divided by negative 2 is going to be a positive 3, a to the 3rd. And then we're dividing out the last term by negative 2. 10 divided by negative 2 is a negative 5. Now we have two big groups here. We have the first big group and the second big group. Factoring by grouping, out of those two groups, we see the greatest common factor. Notice that both of these terms, these two big groups, have a common factor of 3a squared minus 5. So 3a squared minus 5 is what we're going to factor out of both of those two big groups. And when you factor that out, that 3a squared minus 5 from the first group and the 3a squared minus 5 from the second group, what you'll have left here is the 3a squared minus 5s will, 3a cubed, sorry, minus 5. Factor out the 3a cubed minus 5. What you'll have left is 5a to the 3rd minus 2. So in factored form, the polynomial can be written as the quantity 3a to the 3rd minus 5 times the quantity 5a to the 3rd minus 2. For example C, we have the polynomial 15x to the 3rd minus 25x squared y minus 6xy squared plus 10y cubed. Looking at factoring by using the grouping method, splitting that up into two groups, and the greatest common factor for the first group of 15x cubed minus 25x squared y is 5x squared. And the GCF of the second group, 6xy squared plus 10y cubed, is going to be a negative 2y squared. And the reason why we use a negative there is because the coefficient of the third term is negative. So let's take our polynomial, 15x to the 3rd minus 25x squared y, minus 6xy squared plus 10y to the 3rd, and we're factoring by grouping in the first group the greatest common factor of 5x squared. If you divide both of those terms by 5x squared in the first group, what you have left is 15 divided by 5 is 3, and x cubed divided by x is x. The negative 25 divided by 5 is negative 5, and the x squared divided by x squared is 1, and the y. Now in the second grouping, the GCF is negative 2y squared, so we have a minus 2y squared, and we're going to multiply that by what we get when we factor out the negative 2y squared from both of those terms. The negative 6 divided by the negative 2 is a positive 3. X, y squares will divide out, and then the 10 divided by 2 is plus 5. Y cubed divided by y squared is y. Now we've got two big groups here. We've got our first group, 5x squared times the quantity 3x minus 5, and the second group is the negative 2y squared times the quantity 3x, that should have been a negative, minus 5y. So the greatest common factor of both of those is 3x minus 5y. They both have the 3x minus 5y in common. So if you were to divide that out, you would have left 5x squared minus 2y squared. So our final answer, by factoring that polynomial using the grouping method, we get the quantity 3x minus 5y times the quantity 5x squared minus 2y squared.